and my fellow classmate. So I will be presenting, and me and my group members will be presenting this Group 2 evaluation for this QUS 3216 measurement for advanced building works. So let us introduce our team, about our team. So our team members, first is me, I'm the group leader, and Tan Chin Fong, group member, and Lee Chen Kai, group member. So this is our really nice photos, you can see. And then next, so how we distribute our tasks. So first, me as a leader, I need to coordinate all the responsibilities of the team and ensures that its goals are aligned and successfully met. And I'm in charge of the roof structure elements. And for Tan Chin Fong, he is a thinker, so he provides direction and suggestions for the materials content, in charge of the roof covering elements, and edit and revise the completed works. And as for Chen Kai, he is a challenger. He takes care of the specification concerns of the roof element according to SNM2, and he also in charge of the rainwater downpipe element. And also he needs to understand the nature and calculation of the measurement work, because all of us, we are in charge of one of the elements, one of the part. All of us need to know each other what they do or how they measure, so that we can all understand what we have been done. Next. So our weekly updates include this, so you all can see how we progress our work. So first, during week 7, first we discuss the type of building to evaluate, and then week 8 we go for church briefing, and then week 9 we distribute the tasks and discuss through Google Meet. And as for week 10, we go to the site visit and we create our taking off list, our drawing, our sketches. As for week 11, we evaluate all the measurement work, and during the week 12, we to compile everything and revise and checking. And then we also set a meeting to discuss is there any mistake or is there any clarification need to be done. And lastly, for this week 13 is our presentation. So next, so we will begin our building project. So our building project is Wesley Methodist Church. It's located in Seremban and is founded in 1920s. Its purpose is to cater to the ways of Chinese immigrants. Some of them were Christians already, who flooded into the area following the discovery of tin ore in 1870. So the location of this church is at Jalan Lintang, Bandar Seremban, Negeri Sembilan. So it's near terminal, the bus stop, Terminal 1, and also near the KTM. And surrounding is we got the secondary school, primary school, also named Wesley. And then the church mission is to church without walls, and its mission is to loving God and touching lives. So the Anglo Chinese School SMK Methodist was founded about the same time and shares the same compound with the church. So this church has been through lots of demolition works throughout the years, because it's a quite historical building. And then the second part of the building is the extension building. This one. This one is the extension part of the building. So the type of building is a Methodist church, a religious building, and the type of roof is gable roof, and the type of work is wood work, except for the metal work for the vessel plates and the bolts and nuts. So this is the overall view from Google Map and a reference where is the location of it. This is the overall view of the church. This is the best photo I can find online, and this is been provided by the church website. So this is the interior part of the church building. We have been given permission to take photographs inside. So these two will be the main part of the church. This one is the extension part of it, and this one is the back of the church. So our group site visit. So after speaking with the person in charge from the church office, our site visit is scheduled on 3rd of November, Thursday morning. So we arrived at 9 a.m. to meet with Miss Kiran from church office for the visiting work. So we took a lot of pictures for the measurement work. We are also discussing on the roof structure, roof coverings, and rainwater downpipes. So this is our acknowledgement and appreciation. So we like to express our gratitude to Ms. Kiran and the church authorities for the opportunity to have a site visit. This is Ms. Kiran. Because it's supposedly be another person in charge, but he was having some issues. So Ms. Kiran will be the one who guide us to this church visit. So now we will be presenting our measurement work prepared by presenting sequence. First is me, Sun Chi, then is Qin Feng, and then Chen Kai. So how does our group prepare the measurement work? So first we need to list down the roof element of the church, and then next we need to discuss among our team members on the identity of each possible element, and then for third we need to conclude a final list, taking off list for the measurement and taking off list, and then fourth we need to conduct the taking off list along with some research on the internet on the material and assumption, because the church didn't provide us on the construction drawings or any other related information. And then next we need to refer to SMM2 and lecture notes to elaborate the measurement work. So this is the layout plan sketch by our group. So we using AutoCAD. I think this one enlarged purposely. So this is the main part of the building. This is the extension part. So all of them are gable roof. And then next. So this is the evaluation sketch by our group. This one is the front evaluation. This is the rear elevation. This one, I think, I'm sorry for the inconvenience because I think this has enlarged a bit. So this one is the left elevation, and this one is the right elevation. So it's not to scale because we just sketch, let you have a better understanding. So this is some church image taken by our group members. As you can see, this is quite a historical building and is well maintained. So this is our section of assumed roof structure, not to scale, and we also refer to our tutorial, our lecture notes, and also some research online. So this is the assumed roof detail. As per usual, is mostly identical to our tutorial, to our lecture notes, and as for this. Okay. So now I will be presenting the roof structure prepared by me. So first, we need to look at the taking off this structure. Madam, excuse me. Hello, madam.
Yes,
Hello.
yes, yes.
I think I need a moment because this PDF doesn't show entirely the screen. Can you give me a moment to change the PDF? Uh,
Okay.
can you see the entire slide? Because from my part, I cannot see the entire slide.
I can see the roof structure. Take it off, please. Is it the one that you want to share?
Yes. Can you see the 10th item? Because I can't see from my part, my
Yes, I
side.
can. I can see 10 items.
Okay, then I will proceed. I continue proceed that. Okay, so for the roof structure, we have the sound pressure treated group B timber as described. We have the wall plates, the pitch roof members, and the ridge board. So all of them are calculated in meters according to the clause M2.1E. Uh, is measure linear meter and describes the section and then the types of quality of the timber treatment to timber. This one. And then this one also is the same. As for the metal work, as described, for this we don't have the rough surface because it's covered with ceiling finishes. And then next is the metal work. I'm sorry. Next is the metal work as described. We have the gusset plate, and we got five different sizes. All is measured in number according to clause M.30. And then holes in timber as described, all is grouped together because they are all in the same diameter. So next. So for the first item, this one is the wall plates. So for the wall plates, So we calculate as like this. On the wall plate curve, we got A, B, C, and D. So here is the internal corner because here is a brick wall. The brick wall is only where we can see all the external part of the building. Actually, in the internal, it doesn't have brick wall because you can access to it. So the calculation method is like this, and you need to uh, further uh, on the internal corner got 2, so you need to times 2 and 2 and then times 2 and then 200. This is assumed, all is assumed. And next, so for the pitch room members, for our group, we assume all pitch room members are in the same dimension. So first, the calculation method is the rafters numbers of each area. So this is how we evaluate. And then for length A, B, C, D, we do it like this because we show you how to measure the method because we don't have the exact dimension of it. So as for length ABC, you know ABC, and then you need to deduct the gable and verge for B and D, and then for wall thickness, clearance, and length of rafters, all is needed to be deducted, and then we assume the center to center is 600, and then it's to be divided, and then we need to the outcoming answer need to plus 1, and then we got the final answer for the numbers of rafters of each area. And then so continue with the rafter. So in order to know the length of each rafter, we need to calculate the house span area each one. So we need to add overhang here, and then we need to deduct the ridge board here because we put it as center like this. And then the length of rafter we can calculate by using cosine rule. Total house span divided by cosine. So this one we set as like this because for A, B, and C is 45 degrees and for rafter D is 25 degrees. So also you need to, after you sloping length, you also need to add the cutting length of at the end 0.075 is standard at here. So next. Okay, so this one is the ceiling joist. For the ceiling joist, because we calculate as entire, so we need to times 2 the length of X. It's also for the length of the ends here. So it's the total length of ceiling joist. So we no need to times 2 because due to the side cuts already include the entire length of ceiling joist for both sides. So we only multiply by the total number of each area rafter, like A1 and A2. We only use one of the numbers because they are the same. So this is the post. So we have the post here and then the strut. So for post A, B, and C, they are 45 degrees. I arrange like this for you to know the difference. And then next one is the 25 degrees, same as the strut 45 and strut 25 degrees. So we all need to times 2 because I didn't include the entire. So we want x1 like this, and then 2 times the number of the rafter A, B, C, and D. So here we don't have A1, A2, or B1, B2 like this. We calculate as whole because here we did times 2. So this one is the this one is the note of rafter to be deducted. Because this is a extension part, I think if it's not extension part, they already didn't you need to deduct, but it's the extension part. They also need to remove here so they can extend this area. And also for this tower, they also need to deduct the overhang rafter between area A and B here and then here the tower. So the note of rafter to be deducted is length of y1 and y2 add together, and then we divide by 600, and then we get the nose and then plus 1. Then you get the total number of the rafter. And then the length of rafter can be taken by the overhang divided by cos 45, and then the sloping length of the rafter. Here got an error. You also need to add the cutting length. I'm sorry for this inconvenience. So next we have the ridge board. So for the ridge board is similar to the ridge tiles later. So the ridge board is at the orange line that on this sketch. So the brickwork is must be excluded until the very end of it. So all of this is measured in meters, and for this label of forming rough surface as described, so I provided a image we taken on the site, so we no need to measure due to the installation of ceiling finishes. The rough surface is only required for exposed surface of the rafters. So next, the metalwork as described. So we got five different kinds of dimension. First, we got the 25 degrees and 45 degrees pitch roof in A, B, C, and D area. So the looking is like this. So here you got two knots and then here one knot. So together we got three here. So this red circle is referred to the total number of ceiling joists already times two, because this is only half span of it. So this is an example of the calculation method. So here all is calculated in numbers. So next is the bolts and nuts. So for the bolts and nuts, it's calculated in number and then according to clause M.30. So we take the quantity from the metalwork also plate. And then each type of the roof structure requires 4 nodes of bolts and nuts. Each we got 4, 4, 4, 4, 4. So need to 4 times 4 nodes of bolts and nuts for one half span. And then next for the holes in timber as described, so we is reading 30 meters diameter holes through 50 mm thick timbers for bolts and nuts. So it's also calculated in numbers according to clause M.28.1.8. So how we calculate this is to take the quantity from metalwork, bolt and nut from page this one. This one, I'm sorry. Bolt and nut page. Yes, this one. So next, I will pass to Chin Feng to continue the roof coverings. Chin Feng?
Yes.